Good day, and I am Larry Pruss. I'm the Managing Director of our Digital Asset Advisory and Emerging Technology practice, and I am the host of Tech Talks, SRM Tech Talks, and we explore topics at the intersection of traditional finance and emerging technology. We do this meeting every other week. This week happens to fall right before a holiday, so while I will be canceling the meeting, I will be recording this and sharing it with our participants. So with that, I'm going to be talking today about the implications of large language models and unlocking the power of generative AI in financial services. So this is really going to be a primer on large language models, which is a type of generative AI. In my presentation, we're going to delve into the world of artificial intelligence, large language models, and the coming impact on financial institutions. We will explore the following areas. We're going to discuss AI's impact on the landscape of finance, everything from predictive analytics to personalized recommendations. We'll also discuss some real-world use cases where AI shines, from turbocharging fraud detection to personalizing content management. And then as we embrace AI, we're also going to confront its challenges. We're going to talk today about bias, data security, and compliance risks of AI. And we'll also talk about how AI might impact jobs, what new skills will be in demand. We'll do a quick regulatory review of the landscape. It's going to be short. And then we'll end with some knowledge and action takeaways for everybody. So before I get too far, for those of you who aren't familiar with strategic resource management, also known as SRM, we'll do a quick overview. We are a full services advisory firm based in Memphis, Tennessee. We offer various solutions for financial institutions, everything from strategy development, digital transformation. We have expertise in payments. We do quite a bit of third-party vendor sourcing and evaluation. And then we have a number of other products around customer member engagement. So enough on that. Let's talk about artificial intelligence. So I bet many of you recognize at least a few of these AIs. We have Terminators from the movie Rise of the Machines. We have HAL 9000 from 2001 Space Odyssey. Jarvis, a favorite of mine from the Iron Man series. And Ava, the AI robot from Ex Machina. It's unclear if the future will really produce any of these type of AIs. Probably hope not, but what we have today is a little bit more like this. AI is already embedded in a lot of products that we use. Tesla uses it to assist in driving. Personal assistants like Alexa and Siri use AI to understand language and respond to our queries. Netflix and Spotify use AI to determine what movies or songs we might like. Airlines use AI to maximize their ticket pricing, and Roomba uses AI to decide where to vacuum. All of these examples are what we call predictive artificial intelligence. The power of predictive artificial intelligence can really be pretty substantial. For example, 35% of Amazon's revenue comes from the predictive shopping recommendations that it makes. With large language models, these are solutions like ChatGPT. We now have a technology that can understand our written language, generate entirely new output. And these generative AIs can write poetry, code, produce images, even video. In short, there's a new class of AI that can create. In this capacity or capability is going to start touching every aspect of our lives. So as we go through this presentation, it'll be useful to be thinking about the differences between predictive AI, which could be used for making product recommendations, versus generative AI, things like ChatGPT that is going to produce entirely new content. So your IT leaders are already know just how important AI is, especially for approving budgets. All joking aside, AI is expected to have a major impact on how companies drive revenue and cut expenses. Goldman Sachs suggests that AI will boost U.S. GDP growth this year by about half a percentage point, which is very substantial. There's a great analogy by Tim Havens. He's the Associate Dean of Research, College of Computing, Director of Institute of Computing Cyber Systems. He explains AI as a way that a child learns to ride a bike. When we're helping a child learn how to ride a bike, we don't tell them to move their left foot in a circle on the left pedal in the forward direction while keeping your right foot running your right foot in a circle. Literally give them a push, tell them to keep the bike upright and pointed forward, and they're going to fall a few times, honing their skills each time they fall. That's AI in a nutshell, and that's really how Tim Havens describes AI. By the way, this photo, as well as most of the photos in this presentation, were produced by AI. As I present the materials today, I want you to be thinking about two key considerations. First, AI capabilities are really a spectrum of capabilities. The analogy I find useful is comparing AI to electromagnetic spectrum, where higher wavelengths mean more energy, and at least with radio waves, more capabilities to carry data. That's why 5G is better than 3G. With AI, as we add more data and more compute power, we get more capabilities. Second, I'd like you to start thinking about about artificial intelligence really as more augmented intelligence. So it's not AI or the absence of AI, it's AI plus human intelligence. AI is not going to replace human intelligence, at least not anytime soon. Rather, it will be used to augment it. Generative AI has the capability to produce realistic audio, images, video, and more. All of these pictures on this slide were created by AI. These people do not exist. AI has the ability to not just produce photos, but video as well. In fact, OpenAI recently introduced a video generation model called Sora. This model appears to have generated an emergent capability in that it has learned physics. It is no longer just manipulating pixels in 2D. Another emergent capability is that AI has learned languages, even ones that it wasn't trained on. We're not entirely sure how AI is gaining these additional capabilities, but what we can observe is that as we feed AI more data plus more compute, we get more skills. One of the downsides, obviously, of increasing AI capabilities is that it's being used to create deep fakes and synthetic identities and help with driving additional fraud, and that's a problem. These early capabilities in producing videos, producing pictures, coming up with synthetic identities are really truly amazing, possibly concerning, but they certainly illustrate the promise as well as dangers of AI. What we are collectively experiencing is an evolution of technology. AI is just the latest chapter in that evolution. With every major technology innovation, there were incumbents that pushed back, whether that was the candle makers, horseshoe makers, newspapers, and even central banks. AI is just the latest evolutionary technology. However, AI is not new. It's been around since about the 1940s when a scientist named Alan Turing first introduced the concept of thinking machines. Alan is considered the father of modern computer science and is famous for decoding the encryption of the German Enigma machines during the Second World War. He also detailed a procedure known as the Turing test, forming the basis for measuring artificial intelligence. Next, let's explore some definitions of AI. Artificial intelligence, or AI, involves using computers to do things that traditionally require human intelligence. AI can process large amounts of data in ways that humans cannot. AI can recognize patterns in that data and make decisions and/or provide insights. Major advances in AI, specifically large language models, or LLMs, has come with massive increases in processing power, data availability, cheap electricity, and the use of innovations like the transformer architecture that ChatGPT uses. There are many different approaches to AI, but some of the more common ones include machine learning, which is really a subdomain of artificial intelligence that focuses on developing systems that learn or improve performance based on the data they ingest. Deep learning is a type of machine learning that uses artificial neural networks, similar to the way the brain works, to learn data. Natural language processing is a type of AI that allows machines to understand and process human language. And large language models are a type of natural language processing that's trained on massive data sets of data of text and code. LLMs are able to learn the statistical relationships between words and phrases and can be used for a variety of tasks such as text generation, translation, question answering, and more. These are generative in that they generate results based on input. In fact, the GPT in ChatGPT stands for generative pre-trained transformer. These work much like a fancy autocompute. LLMs are pattern matching systems, and while they excel at language, LLMs can discover patterns in any data, including financial or customer data. That's what makes them valuable. Other types of AI include image generators such as OpenAI's DALL-E and Midjourney. AI is not new. We just call it by different names. In the 1900s, we had slide rules, the abacus, later the mechanical computation machines like the Dalton. In the 1950s, we were introduced to the concept of microcomputing, the first compiler in COBOL language. We observed early concepts of artificial intelligence along with the proposed test, the imitation game, also called the Turing test. This is a test of the machine's ability to exhibit intelligence behavior equivalent to or indistinguishable from that of a human. Later in the 60s and 70s, we saw innovations of magnetic storage and the invention of the microprocessor. In 2000, the microprocessor became smaller, storage became cheaper, processing dramatically faster, and bandwidth increased. Artificial intelligence saw great strides. In 1997, Deep Blue beat the world chess champion. In 2006, companies like Twitter, Facebook, and Netflix started using AI in their UX algorithms. 2011, IBM's Watson beat a Jeopardy champion. Then in 2010 through 2020, we started seeing AI neural networks. These are the ones that are used to identify fraud by credit card companies. They could recognize images by showing it unlabeled images with no other background information. So images of, say, cats, dogs, fraud, whatever it may be, by, again, training it on unlabeled images without any other background information. In 2020, OpenAI started beta testing ChatGPT 3.0. This is a model that uses deep learning to create code, poetry, and other writing tasks almost indistinguishable from humans. 2021 and 2022, OpenAI developed DALL-E, which can process and understand images. And now in 2024, we have the latest versions of ChatGPT, Gemini, Bing, and Claude, which are trained on huge quantities of data and can take inputs such as text, audio, video, and generate entirely new creative content. It's worth considering that most of the significant advances have happened recently in the past few years. In short, AI capabilities are accelerating. Artificial intelligence is really about automating tasks that humans currently do, particularly lower value repetitive tasks. As mentioned before, AI is a spectrum of capabilities. Starting at the most basic in the lower left-hand corner, moving to the most complex, upper right-hand corner, examples of simple AI, we'll start with the examples of simple AI. These are rule-based systems like RPA, or robotics process automation. These are intelligent processes that can provide binary outcomes like a credit or fraud decision, a yes or a no. Intelligent automation is more advanced. An example would be predicting marketing response or likelihood of charge-off. These tend to be probabilistic outcomes. Then moving into more complex, we run into narrow AI, which is still task-based, meaning that they only do one task well, but again, more complex than, say, intelligent automation. Examples of narrow AI would be chatbots, threat identification via video, advanced personal assistance, and providing financial advice. And finally, in the upper right-hand corner, we come to artificial generative or general intelligence. And this is the most advanced AI in existence, maybe the most advanced that we'll see in, say, in the future or from tomorrow. It can generate entirely new content based on what is learned from existing content, often via unsupervised learning. Generative AI includes large language models, image models, video models, or task models. There are also what are called foundational models that have a wide range of multimodal capabilities, both for inputs and outputs. ChatGPT is an example of a generative large language model, but the capabilities of LLM have proven to be much broader than just language and extend into multimodal analysis, data search, summary, synthesis, planning, and even robotics. Here we have an example of providing some input, in this case, photos of cats as training data. We run it through the generative model, we introduce some random noise, and then it generates a sample, a picture of a cat. However, this cat does not exist. This cat was generated using inputs from the training data. Getting good generative content from an LLM is dependent on your ability to ask the right questions. Here are some elements of a good prompt design. So you can provide context, which is a brief introduction of the topic. You can provide, decide what kind of expert persona you want the role of the AI to undertake, such as historian or nutritionist. You can add verbs to guide the output required, such as compare, summarize, analyze. You can provide length and output type. So if you want a Word document, you can limit it to a couple hundred words. You can ask for it in bullet point summary. You can provide it tasks and objectives, such as develop a marketing plan or a business plan. You can offer tone as well. So you can say the tone for the output could be formal, technical, funny. You can give it a target audience. So you could say, explain it to me like I'm a 5-year-old, or explain it to me like I'm an academic. You can ask for it to provide references. You can give a purpose, goal, or intent, such as to persuade, entertain, or inform. You can use keywords that you want it to focus on, such as sustainability or productivity. And then you can provide any other special instructions you might want or clarification. But again, your ability to get the output is really dependent on your ability to write a good question or a prompt. This slide highlights some of the applications of generative AI. They range from complex text-based solutions, writing code, generating images, speech, video, and even rendering 3D models. So what does all this mean for financial institutions? Well, in practical terms, financial institutions can think of generative AI or large language models as bringing new automation capabilities. They unlock tasks which previously would have been impossible or very costly to automate. They can make existing automation technologies faster and better. In short, they enable a new generation of more efficient solutions and extended capabilities. The automation adoption cycle is also a cautionary tale. It takes the market a long time to transition off obsolete technology, but ultimately the world moves on, and those that don't adapt are acquired or modernized by those that do. This adoption cycle can happen much faster than it used to. Consider the case of taxis and the competition being rideshare apps like Uber and Lyft. Due to the application of a combination of new technologies, rideshare apps overtook traditional taxis in less than a decade. In the end, technology and automation wins. In addition to automation, generative AI and large language models have other applications for banking. Here are some specific ones. AI can help detect fraudulent activities by analyzing large volumes of data and identify suspicious patterns. Machine learning algorithms can learn to detect fraud more accurately over time, reducing the likelihood of those activities going undetected. Generative AI could potentially be used to identify and prepare for new fraud schemes, even before the criminals might start employing these strategies. AI-powered chatbots can perform routine customer service actions like account balance queries, loan application status update, processing deceased accounts, write to offsets, ACH returns, stop processing requests, and it can be used to classify calls based on sentiment or to gain insights into your customer or member interactions. You can use it to identify credit risk, which is obviously a crucial part of lending, and it can help analyze borrower data to identify patterns that could be indicative of potential default. AI can also analyze other risk factors, such as economic indicators, enabling banks and credit unions to make more informed lending decisions. Hyper-personalization is becoming increasingly important in marketing, and AI can help banks and credit unions create personalized marketing campaigns by analyzing customer or member data to identify preferences, needs, and behavioral patterns. Analyzing investment opportunities is a crucial part of managing a financial institution's assets, and AI can analyze financial data and identify potential risks and rewards associated with different investment opportunities. The loan underwriting process is a time-consuming and labor-intensive process involving tasks such as data entry, credit checks, and document processing. AI can automate many of these routine tasks, freeing up employees to focus on more complex tasks. And finally, AI can help financial institutions stay compliant by analyzing data and identifying potential compliance violations. Furthermore, it can help automate compliance tasks such as documentation and reporting. These are just some of the examples. This is an ever-growing field with lots of ever-growing use cases as well. Next is some specific examples. While there's a lot of chatter that AI isn't ready for prime time, results across the world and globe are beginning to say differently. Klarna, the Swedish buy now, pay later solution provider, recently released some very impressive details on the use of its OpenAI-powered assistant. Their AI service solution managed 2.3 million conversations, representing 2/3 of Klarna's customer service chats, and operating at a capacity of 700 full-time agents. Their AI solution achieves customer satisfaction scores on par with human agents and enhanced accuracy in error resolution, leading to a 25% decrease in repeated inquiries. It also reduced customer inquiries from 11 minutes to under 2 minutes. It's available across 23 markets, available 24/7, and is proficient in 35 languages. Finally, it's estimated to generate a $40 million improvement in profit for Klarna. The specific bank examples: Bank of America uses AI to power its chatbot Erica. Charles Schwab uses it to personalize investment advice. Moody's uses it to assess creditworthiness. JP Morgan uses it to detect fraud. Citibank uses it to personalize marketing campaigns, and they're going to roll out a GitHub Copilot AI to all of its software developers, about 40,000 employees to assist in software development. So why should financial institutions care? The previous examples were from large banks that can afford to be early adopters. Many of you are thinking it's probably better to be a fast follower. Perhaps. But we would argue that financial institutions continue to need to be at the forefront of evolving to new offers, new products, become more efficient, better serve clients, and compete with fintechs like Klarna, who are embracing AI and continue to have a more flexible regulatory environment. I believe this slide illustrates that point. Additionally, the bar chart highlights software engineer companies who are looking to hire workers with AI experience. These software companies are the fintechs of tomorrow. The takeaway here is you want to build for the capabilities of tomorrow, not just for today. And you may want to consider leveraging the same technologies as your competitors. Furthermore, as with Klarna, there are potential positive impacts of lowering operating costs. It's estimated that by 2030, there's going to be a collective $1 trillion, trillion with a T, in savings, or a 22% reduction in operating costs for the financial services industry. This will come from using AI in digital identity verification, predicting member churn, predictive analytics for marketing, dynamic pricing, branch efficiency, and staffing. So what's the immediate future of large language models? Well, it's still early. Innovation, particularly innovation in automation, tends to follow a pattern of paradigm shift followed by years of the industry integrating these new capabilities and adapting operations to make best use of them. Many banking technologies have followed roughly the same pattern. This would include ATMs, credit cards, EMV, contactless, and digital banking. While the initial uptake is often slow, with the early value coming primarily from industries in which the technology is turnkey and highly valuable, it generally accelerates as 1, the technology matures, 2, as businesses adapt to their operations, and 3, as second-order ecosystem effects start to magnify or multiply the impact. On this slide are categories of tasks which LLMs are particularly good at without a lot of specialized training, prompting, or fine-tuning. Using AI for scale personalized emails and for marketing campaigns is a very strong use case. You can feed AI contextual data from your CRM and have the AI craft personalized messages. Search and summary is another strong use case. It's not perfect, but it's improving with the models being fine-tuned to industry verticals. Internal knowledge management, the capability allows one to provide company-specific data sets as inputs, and then the AI can call upon that data in an efficient way, often finding previously unknown insights. Company-specific AIs are great for providing training for new employees, for answering specific product-level questions as well. Unstructured data analysis can be conducted by AI and can lead to insights previously unknown. And finally, large language models are able to write, review, critique, and improve code, even going as far as writing fully functional applications almost entirely on their own. We find it helpful to think of value generation in 2 distinct categories. 1, using large language models as a specialized tool, typically unique high-value use cases like identifying fraud or marketing opportunities. And 2, as a more general multi-tool. In the short term, especially for smaller FIs, much of the value generated by LLMs will come from improving a wide variety of tasks by a small amount. This is a concept of using AI as a multi-tool. FIs are excited about the prospect of increasing the quality of work, especially from less knowledgeable and less experienced employees. AI can answer questions like, what are the details of Reg Z as it pertains to this dispute? Is this vendor contract wording sound? What are my competitors' rates and products? Which customers on this list live within 3 blocks of a branch and have opened a marketing email this year? Using AI as a multi-tool enables your employees to work better and more efficiently. Typically, this would be accomplished by stock or mostly stock models and plugins. When using AI as a multi-tool, it is critical to have the appropriate guardrails via policy monitoring and education. We'll address this in a future slide. There are a few different modes of AI model sourcing. This would be embedded AIs, AIs via application protocol interfaces or APIs, and developing your own AI platform. A good example of embedded AI is Bing's Copilot that's increasingly being integrated with the Microsoft solutions. Embedded AI is not a competitive advantage, but rather raises the bar for everyone using these tools. Application Protocol Interface, or API access, can provide some competitive advantages, but you're still using someone else's AI solution. You're just using the API to access it. And those solutions are typically specialized AI functions, something like offered by tools like Posh AI. However, while these tools can be very powerful, your competitors also have access to these same tools. Thus, the competitive advantage may be limited. Furthermore, there may be concerns about how the AI is utilizing your data. Finally, a platform approach allows for utilizing foundational AI platforms and your own data to create an AI specific for your business. This is the most competitive approach, but is also the most expensive and complicated approach. As for AI development, over the next decade, we're going to see the rise of an entirely new AI agent ecosystem. These agents will be large networks of interconnected AI that will push enterprises to think about their intelligence and automation strategies in fundamentally different ways. Today, most AI strategies are narrowly focused on assisting in task and function. To the extent that AI acts, it's acting as a solitary actor, rather than an ecosystem of independent parts. But as AI evolves into agents, automated systems will make decisions and take actions on their own. Agents won't just advise humans, but they will act on humans' behalf. AI will keep generating text, images, and insights, but agents will decide for themselves what to do with it. An example of how this might be used in financial institutions is around branch security. A number of AIs could use a combination of video, audio, and other inputs, perhaps social connections, to determine the threat level of an individual entering the branch. Depending on the action of that threat, another AI could then decide on the appropriate action, providing an early warning, perhaps locking the turnstile, or even notifying authorities with appropriate details. As agents are prompted to become our colleagues and our proxies, we will need to reimagine the future of tech and talent together. It's not just about new skills, it's about ensuring that the agents share our values and goals. Agents will help build our future world, and it's our job to make sure it's one we all want to live in. I've talked a lot about AI capabilities, but these capabilities are not without risk. There are several key risks arising from quirks on how LLMs function in the current security landscape. Fundamentally, large language models are about pattern matching and predicting some output based on data used to train them. They're not searching a database and returning the same value every time. They are literally creating answers. They're not referencing the correct answer, they're creating an answer. This means that sometimes they'll return plausible sounding incorrect interpretations. These errors are called hallucinations, and they are just a consequence of how the technology works. However, as you may imagine, this behavior poses regulatory compliance and reputational risk. Thus, it's critical to have some amount of expert oversight for most use cases. One way of minimizing hallucinations is to provide the model with more context or constraints. Additionally, large language models have made a lot of progress when they are fine-tuned, and in general, error rates are decreasing. There are also data privacy and security risks with utilizing AI. While some AI providers have expanded privacy protections, we continue to see examples where private company data ends up part of a training data set or are leaked to the public. For example, using a little-known hack, researchers recently prompted ChatGPT to repeat the word poem forever. The chatbot initially responded by repeating the word poem as instructed, but after a few hundred times, ChatGPT began generating often nonsensical output, a small fraction of which included memorized training data, such as individuals' email signature and personal contact information. Obviously a problem. Data is becoming increasingly monetized. That data protection is likely to become a big point of contention in AI vendor contracts. This is important because in the future, large language models will be embedded in so many of the solutions and processes that setting data security standards for both employees and vendors needs to be a priority. Data is your competitive advantage, and you'll want to protect it. Finally, AI bias is an important consideration. Big commercial AI models like ChatGPT are trained on huge swaths of the internet and are inherently biased in their data sets. Knowing why the AI produced what it did is termed interpretability, and is nearly impossible to achieve for any of the huge models with billions of parameters or inputs. Thus, if you feed a dozen resumes into ChatGPT and it picks, say, candidate A, While providing a good sounding reason, it doesn't necessarily mean the provided reason is true. The AI could actually imply that it's considering years of experience in selecting a candidate, but in actuality, the decision might have been made on whether the name was considered male or female. If you're audited by a regulator or a rejected candidate levies a lawsuit, you effectively have no way to justify that decision. Therefore, until interpretability improves, utilizing LLMs to automate these kinds of decision making is very high risk from a regulatory perspective. Well, of course, we want to minimize the risk of misusage. Your early adopters are also your innovators. They're the ones who will be able to learn and adapt to the coming shifts. You will want to enable them to identify opportunities, to use the technology to do their jobs better, but you will want them to do so while minimizing risk to the enterprise. All that said, don't let perfect be the enemy of good. Humans also make mistakes and are also biased. Just be aware of these limitations as you think through how you might use AI at your financial institution. Now, you may be thinking, let's just ban AI. Well, like alcohol in the 20s, prohibition doesn't work. While 32% of businesses have outright banned the use of generative tools at work, 73% of employees admit to using those tools at work. This apparent disconnect poses risk to institutions and why employee guidance is so critical. Now, how do we address the risks of using AI? Well, we don't want to just draft an AI usage policy. You can even use ChatGPT to draft your AI usage policy. However, what you will really want to do is answer employee questions and gather their concerns. You're also going to want to provide training that outlines the risks and proper use cases. And you're going to want to consider access rules. Perhaps offering a corporate ring-fenced AI that can address usage needs in a way that protects corporate data. And remember, your internal data is going to be everyone's competitive advantage, protecting it at all costs. I'd also like to mention regulation. There's not a lot of AI-specific regulation, but it is coming. In September 2023, the CFPB released guidance which inhibits the use of non-interpretable AI for decisioning, such as loan decisioning. Additionally, National Institute for Standards and Technology, also known as NIST, released an artificial intelligence risk management framework that serves as a voluntary, non-sector specific, use case agnostic guide for developing, deploying, or using AI systems. And the White House Office of Science and Technology Policy released a blueprint for an AI Bill of Rights aimed at governing AI technologies. Now, while there have been a variety of guidance, there are no binding regulations. The EU is probably the furthest along with broad and strict AI regulation, but the AI Act is still in draft form and has a long ways to go before becoming law. In the financial service space, even absent specific regulation, auditors and examiners may find institutions inadequately prepared if they haven't taken steps to mitigate risk around AI. We'd like to take a moment here to address an inevitable question. What does generative AI and large language models mean for jobs? At least in banking, and at least in the short term, AI largely won't eliminate jobs, but it will redefine roles in business processes. Estimates vary pretty wildly around how much AI will impact our business, but some research suggests that 10 to 50% of all work tasks could be impacted. Other analysts predict full automation of more than 40% of our jobs within timelines as short as 5 years. In our view, it's still too early to predict how much automation the LLM architecture will enable, but we do feel confident in saying that large language models are going to be embedded into so much of our future work that it's important now to invest in understanding the strengths and limitations, and that will pay dividends. Being an advanced economy in the US, we collectively face greater risk from AI, but also greater benefits. One expected change will be the rise of what we call AI whisperers. AI whisperers are people that can get the most out of AI tools by crafting the right prompts and context. Some interesting statistics: 30% of companies are looking to hire prompt engineers in 2024. These are people who get the most out of AI capabilities by crafting the right prompts and providing the right context. For example, did you know you can get better results by telling an AI that you will reward it for the best response? Crazy, right? It's a machine, but yet if you tell it that you will reward it, you will get a better response. Likewise, if you can give a range of what's called temperature, and temperature ranging from 0 to 1 will decide on how accurate versus creative the large language model is. So if you set temperature to 0, it's going to be very accurate. If you set it to 1, it's going to be very creative. 70% of companies believe that hiring AI experienced workers give their company a competitive advantage, and 30% say the need for this workers is urgent, while 75% think that hiring prompt engineers will lead to other jobs being eliminated. Capabilities and adoption are really increasing faster than compliance and IT departments can keep up with. It's going to be important to start identifying subject matter experts within or outside your organization to get an understanding of risk, but also how AI can supercharge your organization. Next, to start wrapping things up, I'd like to summarize some key knowledge and action takeaways. So a key knowledge takeaway is that AI is not new. The banking sector has long used AI for fighting fraud, ensuring BSA/AML compliance, providing automated loan approvals, not declines, customer service or client service, automated marketing, and other areas. What is new are large language models, and they've done three important things. One, to make advanced AI capabilities more affordable and usable. Two, to increase the range of automatable tasks. And three, form the foundation of a whole ecosystem of AI-enabled solutions. Large language models can help in many domains, particularly development, marketing, customer service, member service, help desk, compliance, training, and knowledge management. As I said before, don't let perfect be the enemy of good. AIs are already faster than humans, and humans aren't perfect. Thus, AIs just need to be consistently as good as a human to add significant value. And finally, FIs are adopting AI and LLMs, whether they intend to or not, usually via employees or vendors. Everyone in this room likely has someone in their organization using AI in a less than fully safe way. Key action takeaways include, getting a handle on your AI usage within your organization. You can do this by surveying employees, creating a thoughtful, balanced, and regularly updated AI policy, reviewing your AI vendor agreements and partnerships, building in internal expertise through careful, responsible adoption. When looking at use cases in AI vendors, you want to focus on outcomes. Every organization should be setting and measuring KPIs to justify and evaluate their products. Data is more valuable and more important than ever before. If you don't have your systems integrated into a single source of truth, you don't want to sleep until that gets done. You're going to want to conduct horizon scanning and plan for how you'll adapt your operations to best take advantage of new AI capabilities. We're in a time of disruption. For example, LLMs might make custom development so cheap that in the future, it makes more sense to build some of your own software rather than relying on vendors. And you're going to want to develop internal expertise. Or at least contract with a good vendor sourcing and advisory firm. I happen to know one. As a SRM or Strategic Resource Management would be happy to assist you in that. LLMs and other cutting-edge technology will be coming in most institutions primarily via vendors, either through existing vendors adding new capabilities or through partnerships with fintechs. Now we come to the end of the presentation. We covered a lot today. We started with some definitions, including the difference between predictive and generative AI. We then discussed how AI is a spectrum of capabilities. We discussed potential impacts on the landscape of finance and included a few use cases. We talked about different models of AI sourcing and AI agents. We covered the challenges of bias, data security, and compliance. We touched a little bit on potential regulations. In fact, there aren't a lot of those yet. We covered the possible impact of jobs, and we ended with some knowledge and action takeaways. If you found this useful and you'd be interested in having SRM do a similar presentation to your executive team or board, we would be happy to do that. Feel free to reach out to myself or someone at SRM. And if you're interested in use cases, learning more about this or any other topic, again, don't hesitate to reach out. With that, I want to thank you for your attention. This has been a pleasure being able to present this to you today, and everyone have a great day. Take care.